Ukrainian forces have successfully targeted and destroyed a key component of Russia's rare Barnaul-T air defense system, marking another significant setback for Moscow's high-value military assets. The strike specifically hit the 9S-932-1 reconnaissance and control module, a central element of the Barnaul-T platform. Footage of the attack was shared by volunteer activist Serhiy Sternenko, demonstrating the growing sophistication and reach of Ukrainian drone operations on the battlefield. The mission was executed by operators from the Sons of Course unit in the Zaporizhia region, an area that has experienced heavy combat since the escalation of Russia's full-scale invasion. This strike highlights the increasing effectiveness of Ukraine's small, mobile FPV drone teams, which have repeatedly demonstrated their ability to bypass Russian defenses and hit high-value targets with precision. According to open-source intelligence from Oryx, Ukrainian forces have destroyed 3 Barnaul-T systems and captured 4 additional units since the conflict began, signaling that these automated air defense platforms are not invulnerable. Among the captured hardware is a 9S-932-2 combat control vehicle, taken as a trophy by Ukrainian troops. Beyond its immediate tactical significance, the capture of such equipment offers Ukraine valuable intelligence on Russian command and control operations. Studying these systems may provide insights into Russian targeting protocols, coordination strategies, and communication networks, potentially allowing Ukrainian engineers and military planners to devise more effective countermeasures or refine their own air defense tactics. The Barnaul-T system itself is a highly advanced air defense automation platform designed to integrate multiple layers of anti-aircraft defenses. Its primary functions include gathering reconnaissance data on aerial targets, consolidating information from diverse radar networks, calculating flight trajectories, and producing engagement scenarios tailored to specific air defense units. The system distributes targets across various command echelons while taking into account unit capabilities, readiness, positioning, and ammunition status. This centralized approach allows for more efficient engagement, ensuring that threats are allocated to units best positioned to respond, thereby optimizing overall air defense performance. A defining feature of the Barnaul-T system is its interoperability. It can coordinate with a wide range of missile systems and radar stations, including some foreign-made technologies. This capacity for integration enables heterogeneous air defense formations to function as a unified network, enhancing the system's ability to repel concentrated air assaults. By rapidly distributing target data and engagement orders, the Barnaul-T maximizes the chances of neutralizing incoming aircraft or drones, even during complex multi-vector attacks. The system's modular architecture provides flexibility for deployment in diverse operational contexts. Barnaul-T units consist of planning, reconnaissance, and control modules mounted on both wheeled and tracked vehicles, an automation module for manpads, man-portable air defense systems, detachments, and portable fire control modules for platoon-level commanders. This modularity allows the system to be scaled according to mission requirements, whether defending a small forward base or a strategic facility, while also enabling adaptation for export customers with specific operational needs. The recent strike underscores the growing role of small, agile drones in modern warfare. Ukrainian FPV drones, often operated by highly trained volunteers or special units, have consistently proven capable of bypassing traditional air defense networks. Their effectiveness demonstrates a shift in battlefield dynamics, where relatively inexpensive UAVs can inflict significant damage on advanced, expensive systems that were once considered secure. Beyond the immediate tactical impact, these attacks also serve psychological and strategic purposes, signaling to Russian forces that no asset is entirely safe and that their advanced systems remain vulnerable. The broader implications of these operations extend beyond immediate battlefield results. By continuously targeting high-value command and control modules such as the Barnaul-T, Ukraine forces Russia to adapt its deployment strategies, disperse valuable equipment, and implement additional protective measures. Such adjustments can strain logistics, reduce operational efficiency, and create gaps in defense coverage that can be exploited in future operations. Furthermore, repeated losses of sophisticated equipment can have a demoralizing effect on personnel, undermining confidence in their ability to defend strategic positions. Capturing components like the 9S-932-2 combat control vehicle also provides opportunities for reverse engineering and intelligence exploitation. Analysis of the system can reveal operational logic, communication protocols, and coordination methods, offering Ukraine a significant informational advantage. Such insights may contribute to the development of countermeasures, improve operational planning, and even enhance Ukraine's own air defense capabilities. Every captured system, therefore, represents not just a tactical victory but a long-term strategic gain, providing knowledge that can influence the broader course of the conflict. The Barnaul-T's design and functionality reflect broader trends in modern air defense technology, emphasizing integration, automation, and adaptability. By combining real-time data processing, modularity, and interoperability with diverse weapons systems, platforms like Barnaul-T are intended to maximize defensive efficiency against complex aerial threats. Yet, the Ukrainian success demonstrates that innovation, adaptability, and unconventional tactics, particularly the use of drones, can effectively counter even highly automated and integrated networks. The attack in Zaporizhia exemplifies how modern conflicts increasingly rely on technological ingenuity and asymmetric approaches. Small units equipped with advanced UAVs can disrupt sophisticated systems, neutralize high-value targets, and force adversaries into reactive, costly adjustments. This evolving dynamic highlights the importance of intelligence gathering, technical skill, and creative battlefield thinking, where even a single tactical action can produce outsized strategic effects. In conclusion, the destruction of the Barnaul-T's 9S-932-1 module represents both a tactical and symbolic victory for Ukraine. It demonstrates the growing capabilities of Ukrainian FPV drone teams, the vulnerability of Russian high-value air defense assets, and the potential for captured equipment to provide critical intelligence. By targeting such systems, Ukraine not only diminishes Russian defensive strength but also shapes operational behavior, forcing adversaries to adapt in ways that may open further opportunities. The strike underscores the evolving nature of modern warfare, where agility, innovation, and information exploitation are increasingly decisive factors on the battlefield.